So now that we've seen, a variety of methods that can be used to determine, in some sense, where the middle of a data set is, kind of where the data is concentrated. Now we're going to go in the other direction. We're going to look at methods for measuring how spread out a data set is. So the range, like the mid-range, is a very brute force method of thinking about how spread out a data set is. It's literally just the width in the sense that it's the difference between the largest and smallest values. So for my example here, that would be 0.91. That's the largest value. And be careful, right? The data isn't sorted. So yeah, I had to search around there to find the largest one. And 0.38. That's the smallest value. And that difference is 0.53. Now, like the median and the mode, this measurement has no interest in how the data is distributed between those values, which does significantly limit its usefulness. There will, however, be some specific examples that we'll see shortly where we can use this value to get a good estimate of other values that can be harder to calculate. Now, the standard deviation is, by a wide margin, the most commonly used measure of how spread out a data set is. And we'll be referring to it constantly throughout the rest of the class. Now, I know that this probably isn't the prettiest formula you've ever seen, and it can be messy to actually use with real data. Now, fortunately, there are a lot of tools like Excel and scientific calculators that have standard deviation functions that will calculate the value for you. Now, on the next slide, I'm going to walk through an example of calculating this value for a data set by hand, just so you can get an understanding of the formula and its parts. But from then on, I'm going to acknowledge that by modern standards, that's just a tedious exercise. And we'll shift our focus to seeing how to interpret and use the result. So I've got really a very small data set here for us to work with. And I've copied the formula over, right? So let's take a look at the details here. We've got this sigma symbol again. You remember that means to add things up, right? And in the parentheses, we've got an x. So those values come from our data. And we're subtracting this x bar symbol from it. Well, x bar is a symbol that we're going to use for the sample mean. So what this is saying is take every data value, subtract the mean from it, square the result, then add all those values together. Finally, we're going to divide that result by 1 less than the sample size, and then take the square root of the whole thing. All right, so to actually do these calculations here, first, we're going to need that mean. All right, so the sum of all of the values here, if you add all of these up, that is 36, and there are 8 numbers. So the mean, that's that x bar symbol, is 4.5. Okay, for the rest of the calculations, I like to organize everything into a table. All right, so let me get a table here. You can see what I've done so far. I've organized all of the data values into that first column. Okay, so let's see. Next, I'll subtract the mean from each value to get the second column. So this one is going to be 5 minus 4.5, which is 0.5. Then 8 minus 4.5 is 3.5, and I'm going to continue that right all the way down here. So this will be 4.5, negative 1.5, negative 2.5, 0.5, negative 3.5, and negative 1.5. All right, so that's this column, right? Now, for the next column, I'm going to square each of those values, right? I'm going to take this value here and square it. All right, so that gives me, let's see, 0.5 squared is 0.25, for example, and then I'll keep working my way down here. This is 12 and a quarter, 20 and a quarter, a lot of quarters here, 2.25, 6.25, 0.25, 12.25, and 2.25. Okay, now, this x minus x bar squared, that's this expression here. So my next step is going to be to do this sigma part, which says add them all up, right? So if I add all of these up, the total is 56, right? So that's the numerator under the square root here. So this is the square root of 56 divided by n minus 1. Remember, n is the number of data values. That's 8. So this is 8 minus 1. And that's 7. 56 divided by 7. This is the square root of 8, which is approximately 2.82. So that's my standard deviation. Okay, now, as I said on the previous slide, right, I wanted you to see how this works, but as a practical matter, it's going to be much quicker to have Excel or some other computer program do all this work. So now that we've seen how these values are calculated, what I really want you to take away is how to interpret them. And to do that, it helps to know some of the properties that it has. So first, the standard deviation is a measure of how spread out the data is from that central point, right? And that central point is going to be the mean. So, and you saw that in the formula, right? The x minus x bar part. That expression gives you the distance between the mean and every data value. Okay, standard deviation can be 0, but never negative, and that follows from the square root part. Remember that whenever we take the square root of a number, we're always referring to the principal or the positive square root. And finally, the units on the standard deviation are the same as the units for the original data value. So if our data is measuring heights in feet, for example, then the standard deviation will also be measured in feet. Okay, so that's the basics of standard deviation. All right, we've seen how to calculate it and some basic properties that we can expect from it. In the next lecture, we're going to look at kind of a visual interpretation of the standard deviation and see how we can connect it back to the range.